Welcome to Space Tech Insider.
Have you ever looked up at the night sky and wondered how those tiny lights, the satellites, manage to stay up there, circling our planet without falling back down? The key to keeping satellites in space is something called orbital velocity, which is the specific speed a rocket or spacecraft needs to achieve to enter and maintain a stable orbit around a celestial body, like Earth. It is not about flying high enough, but about flying fast enough sideways to continuously fall around the planet. Imagine throwing a ball. The harder you throw it, the further it goes before gravity pulls it to the ground. Now imagine you could throw that ball so incredibly fast that, as it falls, the Earth's curve drops away beneath it at the exact same rate. That is essentially what orbital velocity is. It is the perfect balance between the forward momentum of the rocket and the constant pull of Earth's gravity. If a rocket goes too slow, gravity wins, and it falls back to Earth. If it goes too fast, it will escape Earth's gravity altogether and head into deep space, becoming a flyby or an interplanetary probe. For low Earth orbit, which is where many satellites like Starlink operate, this speed is incredibly fast, around 17,500 miles per hour, or about 7.8 kilometers per second. This speed allows the spacecraft to continuously fall around the Earth without ever hitting it, creating a perpetual orbit. To achieve this, rockets do not just launch straight up. They perform a complex maneuver called a gravity turn, initially ascending vertically, then gradually pitching over to fly more horizontally. This ensures they build up not just altitude, but also the tremendous horizontal speed required for orbit. Engineers carefully calculate the trajectory and engine burns to hit this precise velocity and direction. It is fascinating to know that orbital velocity is not a single number. It varies depending on the altitude and the mass of the celestial body you are orbiting. For example, orbiting the Moon requires a different, slower orbital velocity than orbiting Earth because the Moon has less gravity. And if you want to leave Earth's gravitational pull completely, to travel to Mars for instance, you need to reach an even higher speed called escape velocity, which is around 25,000 miles per hour. This is a critical distinction, as achieving orbit means staying around a planet, while achieving escape velocity means leaving its sphere of influence entirely. So, the next time you see a satellite streaking across the night sky, remember it is not just floating. It is expertly balancing an incredible forward speed with the never-ending pull of Earth's gravity, making sure it stays in a delicate dance high above us, delivering everything from global communications to weather forecasts.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.